All right, number 6, we're going to do some integration. So in 6a, we simply apply the power rule, integrating term by term. So here we have 3 times x to the 6 over 6 minus 4 times x to the 4th over 4 minus 7x squared over 2 plus 2x plus c. All right, so that's a direct application of the power rule. All right, in part B, we'd also like to use the power rule here. So we'd like to divide by square root of x term by term, but let's rewrite square root of x as x to the 1/2. Okay, so now we're going to rewrite that integral. So here we have 5x cubed divided by x to the 1/2. So that's subtracting exponents. We have 6/2 minus 1/2, so that's x to the 5/2 minus 7x to the 1 divided by x to the 1/2, so that would be x to the 1/2. All right, and now we're ready to use the power rule. Let's add 2/2, so that there we have 7/2, adding 1, divide by 7/2. Here let's add 1, so there we have 3/2, divide by 3/2. And see, before we integrate, in order to use the power rule, let's multiply out first so that we have a sum of powers. So here we have 3x squared. Middle term is 15x minus 2x, so that's plus 13x minus 10. Okay, so now we're ready to integrate. So this is equal to, using the power rule, 3x cubed over 3 plus 13x squared over 2 minus 10x plus c. Here in D we have the integral of sine x over cos squared x dx. So let's just keep in mind that we only have 2 methods for integration so far. And one is the power rule, and the other is a use substitution. So obviously we can't do the power rule directly here, so it must be a use substitution. And what we're looking for is an inner function whose derivative is in the integrand. So we know that the derivative of cosine x is sine x, and we have it right here. Actually, the derivative of cosine x is minus sine x, and we have sine x right here. If we rewrite this, it might be a little bit easier to see. So what we have here is sine x times cosine x to the minus 2. In this form, maybe it's a little bit easier to see that if we do this use substitution, u equal cosine x, then right here we have minus du, or du is sine x, is minus sine x dx. So let's do that. The inner function is cosine x. The derivative is minus sine x dx. All right, multiply by minus 1, and we have minus du is equal to sine x dx. And we have sine x dx in our integrand. So let's do our substitution. So we'll substitute minus du, that's for the sine x dx, and here we have u to the minus 2. So this ends up being a simple power rule. Add 1 to this exponent and divide by the new exponent. Okay, so this simplifies to 1 over u, And substituting back, we have 1 over cosine x. Now you might notice that 1 over cosine x, that's actually equal to secant x. And the derivative of secant x is secant x tangent x. Is this secant x tangent x? Remember, the derivative of this should be equal to that, to the integrand. Okay, that's always how we do our check. Well, this actually is equal to secant x tangent x. Let's rewrite. So here's another way of doing this. All right, so this is just another way of doing the same one. Let's rewrite this integrand as, just break it up to 1 over cosine x times sine x over cosine x. This is secant x. Sine over cosine, that's tangent x. So we see that this integrand is actually secant x tangent x, which is the exact derivative of secant x. So we really could have done this without the u substitution, had we noticed that. In E, we have an inner function x squared, and the derivative 2x, well, x is right here. So we have a perfect situation for a u substitution. All right, so we're going to put u equal to x squared. And notice this will turn into essentially secant u tangent u, which is the derivative of secant. So we'll put u equal to x squared. Du is 2x dx. And we'll solve for x dx because that's what we have in the integrand. So we have 1/2 du is equal to x dx. And now we're ready to do our substitution. So for x dx, we're putting 1/2 du. And then we have secant u tangent u. So we know the integrand of secant u tangent u. That's just secant. And now let's substitute back. In f, we have another u substitution. Notice that this inner function has derivative 10x, and we have the x over here. So that's a perfect situation for u substitution. So we'll put u equal to that inner function. And du is 10x dx. And let's solve for x dx. Divide both sides by 10. All right, now we're ready for our substitution. Let's write the integral. Instead of x dx, we're putting 1/10 du. 1 over square root u. All right, so let's rewrite again so we can use the power rule. So we'll write 1 over root u as u to the minus 1/2. Okay, now do the power rule. Minus 1/2 plus 2 over 2 is 1/2. Divide by 1/2, that's multiplied by 2. All right, so this is equal to, let's reduce over here, we have 1/5. And u is 5x squared plus 4. Let's just replace that. So here we have square root 5x squared plus 4. in G we have another u substitution. Here's the inner function. And remember the derivative of 1 over t is minus 1 over t squared. And here we have that 1 over t squared. So we're just going to put u equal to the inner. And du is equal to minus 5 over t squared. Let's divide both sides by minus 5. So we have minus 1/5 du is equal to 1 over t squared dt. And this is 1 over t squared dt. That's what we have in our integrand. So let's do our u substitution. All right, so we're going to substitute minus 1 over 5 du for 1 over t squared dt. And here we have u to the 10th. So let's do our power rule. And now just substitute back. Okay, let's look at h. Well, here's our inner function. The derivative of this inner function is almost equal to, with up to a constant, is equal to 1 over x to the 1/3, which is what we have here. So let's just check that out. Put u equal to that inner function. And let's see what du is. So du is minus 2/3 x to the 2/3 minus 3/3. So there's your minus 1/3. And we have 1 over x to the 1/3, so we have that x to the minus 1/3 in our integrand. So this is appropriate for a u substitution. Let's multiply both sides by minus 3/2 just to get rid of this. So we have x to the minus 1/3 dx is equal to minus 3/2 du. All right, so now we're ready to substitute. So 1 over, oops, sorry, this should be a 3 over here. 1 over x to the 1/3 dx. All right, that's what we have here. We're replacing with minus 3/2 du. And here we have u to the 10th. All right, so power rule and substitute back. In I, we have a linear expression underneath the square root. So we're going to do a u substitution that's a linear substitution. All right, so let's put u equal to x minus 1. And so here we're going to substitute u over here. We'll have 1 over square root u in our integrand. But we have to substitute x as well. So let's solve for x, and we have x is equal to u plus 1. Now taking the derivative, du is equal to dx. So now we're ready to substitute. So we have, in the denominator, we have square root u, and in the numerator we have x, which is u plus 1. So this turns into an integrand that we could integrate using the power rule once we divide by square root u. All right, square root u, that's u to the 1/2. So let's do that. First divide. Rewrite this integrand. U divided by u to the 1/2 is u to the 1/2 plus 1 over u to the 1/2, that's u to the minus 1/2 du. Now we're ready to integrate. This is u to the 3/2 times 2/3 plus u to the minus 1/2 plus 2 over 2 is 1/2. Divide by 1/2 or multiplication by 2. And now substitute back. In J, again, we have a linear u substitution. We'll put u equal to x plus 1. And x is equal to u minus 1. All right, du is equal to dx. So let's substitute, and we have u cubed in the denominator. In the numerator, we have x, which is u minus 1. And dx is equal to du. All right, like before, we have to divide before we use the power rule. So here we have u divided by u cubed, so that's u to the minus 2. Subtract 1 over u cubed, so that's u to the minus 3. Now we're ready for the power rule. Add 1 and divide by the new exponent. Here add 1 and divide by the new exponent. And now we're just substituting back. So here we have x plus 1. And I'll multiply these, I'll get plus. And put, instead of u, let's substitute back x plus 1 plus c.